We have two learning goals today. They're over here. Come over here with me. I can use proportions, so we already know how to set up proportions and use them to problem solve. We're going to use them to solve problems involving geometric figures. That's why I asked you when did you work with geometry last. And then I can use proportions and similar figures. Similar figures was another one of our vocabulary terms, to measure objects indirectly. Okay, so let's first just talk about some of the, let's re-familiarize ourselves with some of these geometric terms. We have these symbols in this column right here, and across from each of them, it shows what that really says, okay? So you should be able to read this properly or know what it's asking you to give. So when we have an XY with a little short line segment above it, how should we read that? How should we read it? It says it right there in your table, come on. Segment XY. It's saying segment XY. So instead of having to write that out in words, that's how we write it symbolically in math. The next one, where we have that, like, it looks like a leaning capital L in front of a capital X, we say that angle X, right? So that's referring to, if we are showing that they're telling us to go refer to angle X. The next one, triangle XYZ. Of course, they just put a little triangle. Where does the XYZ come from? All the points, and then what are those points called at the corners of the triangle? What? There are some angles there, but what are the actual points? What are those? Vertices, that's right. One of them is a vertex. More than one of them, they're called vertices. So X, Y, and Z are the vertices, but we also can call them angles. We can say angle X, angle Y, and angle Z. When XY, the next one here, when XY is written without anything above it, in other words, it doesn't have that little line segment above it, now we're supposed to refer to something else. Instead of just saying line segment XY, what are they asking us for? What about the line segment XY? What about it? What does it say in the table? The length of it. So if they don't have that line segment above it, they're referring to the length of that line segment without the line segment drawn above it. So there's a difference between these two. So you have to make sure that you know what the difference is, what they're referring to. And then when we put a little M in front of an angle, so that stands for the measure of that angle. So when they want you to give the measure of an angle, they'll put a little M in front of it and name it angle, whatever it is. And then we have our is similar to sign. What does similar figures mean? Remember from your vocabulary assignment? What are similar figures? What makes them similar? Riley?
The same shape, but different measurements.
Okay, but different measurements. Like what measurements are different? The angles, the sides, the what? The length of the sides, then? What do you think, class? Do you agree? Do you think he says they're the same shape? Do we agree with that? Anybody know what makes two figures or three figures or however many there are in the group? Anybody know what makes them have the same shape if they're similar? I wrote this on some of your guys' vocabulary assignments. I said, what would make them have the same shape? You should have learned this already. What?
Same angle measurements.
Same angle measurements. If they have the same angle measurements, then they have to have the same shape. But they don't have to have the same side lengths. They can have different side lengths, and so we can have different side lengths, but that's what makes them a different size, but the same shape comes from them having the same angle measure. So when we talk about is similar to, if they have this little, curlicue symbol, that's part of it. It looks like the is not equal to one, but there's only one of them. When it has that, they're telling you that that figure in front of it is similar to the figure behind it, or something about it makes them similar. Okay, so let's write triangle ABC and symbols. Go ahead, do that on your papers. Write triangle ABC and symbols. If you're creating a worksheet for this class and you don't want to write in words, you want your students to have it in mathematical symbols, and then write the mathematical statement. Now they want you to write that in words. How would that be written out? Write that one out on your paper. How would that one be written out? And then when you're finished with that one, you can move on to number 3, and then we'll discuss all 3 of them. Now you have this mathematical statement that you can write in words. So in other words, if I say to you, read that to me, you can be intelligent and show me how it would be. Okay, Avery, come up here and bring your paper, you do number 1. Yep, just use your regular pen skips. Okay, thank you. Number 2. Maybe I should be nice and ask for a volunteer. Avery was just done, so that's why I was checking for that one. Rather volunteer for number 2. You're gonna volunteer. Avery, you're gonna volunteer. Okay, well, I'll let you volunteer now too, since you got picked on the first one. Now you get to be the volunteer. And you sure all know first here before you copy the teacher up here. Okay, thank you, Avery. Volunteer for number 3. Volunteer for number 3. Okay, I'll volunteer you, Riley. Thank you. Thank you. So let's go through this and see if we can agree. Number 1, can we agree with that one? Okay. Now, if the letters are capitalized at the vertices, should we change them to smaller, lowercase? No, leave them capitalized, right? Okay. They reserve a lowercase for the sidelines. Okay, that's where they will put the lowercase letters. Okay, to number 2. Can we agree with number 2? Measure of angle B is equal to 93 degrees. Do we agree with that? Is that what that says? Okay. And how about the last one? Triangle XYZ is similar to triangle ABC. Do we agree with that one? And do we have good spelling going on there? That's always important to remember. We want to have good spelling. Any bad spelling going on there? Anywhere? This is I think this says, right, Avery, A-N-G-L-E? Okay. Is that how we spell angle? Yeah? It's not E-L. What's that word? Angel. Yeah, okay, there's a difference, isn't there? Okay. 90, that's always a tricky one for sometimes for students. They don't know how, even adults. There are lots of adults that spell 90, N-I-N-T-Y, ninty. We need the E in there, 9-T, T-Y, okay? So you want to spell that correctly. I think this says degrees. Yeah, see what I get to try and read on people's papers? Degrees, it's fun. How about the word similar? Did that get spelled correctly? Triangle. Everything's looking good, isn't it? Good job, guys. Okay, now use the information given in the symbols below to label the diagram shown above. Okay, go ahead, go up and label those. Take these 6 measures. You have 6 of them. So you have this one, you have all of these. Read them according to how they are. So this one says the measure of angle X is 38 degrees. So we go up here and we go to
our figure and we say in here, right in here, this is a 38-degree angle. And then, I'll do a couple with you here. This one says the length of xy, remember it doesn't have a line segment above it, so it says the length of xy is 18 centimeters. So we go up to xy and we say, oh, this is an 18 centimeter length. 18 centimeters for the length of line segment xy. Okay, you go ahead and finish those other four. Labeling those figures. So we're just having a little review geometry lesson here. Okay, so now, since they said right here, well, they kind of said right here, we have that triangle XYZ is similar to triangle ABC. There's lots of things we can now assume, right? So, corresponding angles of similar triangles have the same measure. What does corresponding mean? What does that mean? Corresponding, right? They're the same. Well, same what? Shape. Same shape. Well, yeah, that means they're that's what they're saying here. It says the corresponding have the same measure, but what does corresponding mean? How do we know what they mean by corresponding? You're still telling me what they already told me, that they have the same measure. I got to know which angles they're talking about. So we need to decide which ones have are corresponding angles. What makes angles corresponding? What makes sides corresponding in geometric figures? Learn that. Maybe. Then they're in the same relative location. They're in the same relative location. So you know what? If they tell you that they're similar and they don't give you any measures at all to start with, you have to be able to identify which angles would be similar. And here's one of the ways that we can do it. Let's put this right here. Triangle XYZ is similar to triangle ABC. Let's put that there. I never give myself enough room. Never. Right, too big. Okay, let's go back and try again. Okay, triangle XYZ is similar to triangle ABC. Okay, keep trying. In the name, you can tell what's corresponding. So just by the name, that's how you can tell. So angle X would be corresponding with which angle in the other triangle? Okay? A, yeah. These two angles are corresponding because they're in the same relative location in the name and in the triangle. When we go up to the triangle, angle X should, even though they're oriented different, well, they're not laying in the same position, in the same direction, angle A should be in the same relative position in the triangle that angle X is. Okay? So we have those two that are similar. What's the angle that is similar to angle Z?
C.
Angle C. Tell me which side measure corresponds with line segment YZ. Which line segment corresponds with line segment YZ? BC, because YZ and BC are in the same relative location in the name also. So, what is the measure of angle Z then? Which one would it be corresponding to, first of all? Avery?
C.
C. Okay, so Z is corresponding with angle C. So do we know the measure of angle C? Okay, what is it? 49. So we could say then that measure of angle Z is 49 degrees because they're in the same location in the triangle name. Okay, what's the measure of angle A then? Which angle does it correspond to?
38.
Angle X, and do we know the measure of angle X? Yep, it is 38, so we can say, okay, it's gonna be a 38 degree. So these are some of the things we're gonna have to be able to answer when we're setting up our own proportions to solve geometric figures. So write a proportion that relates AB, BC, XY, and YZ. Go ahead, set one up. That's the length of them, by the way, because they don't have that line segment over. So it says, relate the length of AB, the length of BC, the length of XY, and the length of YZ in a proportion model. Set up a proportion with those unknown lengths right now. There are several different ways we can do it, so let's see how many we can come up with. Okay, so far, does anybody have a different one than I do? There's one of them. AB, the length of AB to the length of XY should be the same as the length of BC to the length of YZ. In other words, when we set up ratios of corresponding sides, those ratios should be equal to each other. So, does anybody have a different one? Is that the only way we could set this one up? There are some incorrect ways, and there are more correct ways. No one has a different way? This is it? We all did the same? Okay, let me propose to you, could I do this? Could we do AB to BC is equal to XY over YZ? Could we compare a side of within a triangle to another side within that same triangle, and then do the same thing in the other triangle? And where are the corresponding sides in relation to each other in this proportion model? Instead of above and below, they are instead of across from each other, they are above and below, aren't they? So the corresponding sides, though, are actually across from each other this time instead of above and below like they were in the other one. Let's use this one. Okay, so AB over XY equals BC over YZ. Okay, do we know we're supposed to solve it to find AB? So it's looking to me like X is going to go in for AB. Do we know how long XY is? How long is it? 18, okay. And how about BC? How much? 10, okay. And how about YZ? 15 centimeters. Okay, so where did we get all that information from? Where did all that just come from? The triangles. Okay, so we went up here and we said, okay, in triangle, but wait a minute, we only have 3 sides, so were these the 3 that they used right here? Is that where we got them from? Okay, what if, basically what we're looking for is this one. This is our X this time, isn't it? Okay, so let's go and solve that proportion model. Go ahead and do it, you know how. Let's see if you agree with me when you're done. And then let's decide after we go up to the triangle and put it there, does our answer seem reasonable? Okay, so I got 12 centimeters. Anybody else get that? Okay. So if we go up now and we take side AB and we put a 12 centimeters there, we say that this is 12 centimeters. Does that seem reasonable looking at our drawing? Okay, so we can feel fairly good about it to move on. Questions on this side? Okay, let's go to the back side. And somebody read that statement to me. What does it say? If Okay, if triangle ABC is similar to triangle DEF, then, okay, here's the things that we can assume. If these guys are similar, then the measure of angle A is the same as the measure of angle what? D. We can assume then that if we knew the measure of angle B, we would say we would also know the measure of angle what? E. If we knew the measure of angle C, we could say we would also know the measure of angle F. Okay, so corresponding angles are equal to each other. So we first need to sometimes set up that relationship. Then we can also say that we would be able to set up three ratios. We're going to say we could set up a relationship where three ratios should be equal to each other. So what side does from DEF corresponds with side AB? D what? E. That ratio should be the same as the length of BC, which corresponds to which other length? EF. Well, there's one more side to these triangles. What's the third side of the ABC triangle? AC. We also have side length of AC, which should correspond to which other one's length. It won't be the same as, but it'll correspond to what? DF. Okay, so we have those three relationships that we can set up. How many do we need for proportion? 3? 2. So we could pick now any of those two and put them together in a proportion, but we know that we have that. Okay, so then I want you to do this one for me. If quadrilateral MNOP is similar to quadrilateral WXYZ, and if the length of side NO is 2 centimeters, and the length of XY is 2.8 centimeters, and the length of ZW is 7 centimeters, find the length of PM. How are we going to do that? We don't even have a picture here. Is there a proportion model we could set up that we could then substitute into? In other words, could we take these 4 lengths in names only and first set up a proportion model that'll help us?
Yes.
Okay, so give it to me. NO over, so NO is in the middle, XY is in the middle. Are you following? NO is in the middle, XY is in the middle. Should be the same as that relationship, that ratio should be the same as what other relationship? Well, we've already used up these two. We need a ZW and a PM. So we put PM upstairs here because it needs to be upstairs like the NO was. And then what would we have downstairs? So PM, ZW. Yeah, that works, doesn't it? Okay, so now we can substitute into that and solve our proportion. So go ahead and substitute in. And these are all centimeters, so we can leave our labels off. We're going to call PM X. And we're going to solve our proportion. So go ahead and do that. Well, sometimes we just have to kind of guess how many times we think possibly something might go in. 2.8 is really close to what? 3. 14 is really close to what multiple of 3? 15. So 3 would go into 15 how many times? 5. So let's see if, because we really have to take 14 and divide it by 2.8. So we're really going to do this, right? Here's our new decimal point. We're going to see if it goes in there 5 times. See if it works. 0 times, or 5 times 8 is 40. Carry our, and then we have to carry 4. 5 times 2 is 10. So what's, oh, look at there. It's exactly. So X equals 5 what? Centimeters. Or in other words, the length of PM is 5 centimeters, okay? That's what they were asking us for the length of PM, weren't they? Okay, let's go to page 70, check it out problem. Page 70. I know you're not gonna get any homework time, but this assignment is not due till Thursday, so you're okay. So, for those of you who are clock watchers, don't worry about it, let's go. Page 70. Indirect measurements. In other words, I want you to read about indirect measurement on your own, but I want us also to just do a quick practice problem here together. We're going to do 2B. So we have a woman who is 5.5 feet tall. She casts a shadow that's 3.5 feet long. Let's draw that. We got this woman. She's going to be a stick. She's 5.5 feet tall. And her shadow is 3.5 feet. Shadows are on the ground, right? Okay. And then, what does it say? At the same time, a building has a shadow of 28 feet long. We need to write and solve a proportion to find the height of the building. So we got this building that, do we know how tall it is? No. But we do know its shadow is how long? 28 feet. Now, this is not going to be proportional. It's not going to look like, we're doing an actual scale drawing here. We're just making it look somewhat good. Okay? So, really what's happening here is we could connect these two vertices and we would have a triangle here. So we really have similar figures, and here's the reason why. Because that girl is making a right angle with the ground. That building is making a right angle at the ground. We're doing it at the same time that the sun comes out. They're both doing it at the same time, so that angle up from the angle of measure coming from the sun is the same. Well, if those are the same, then these corner ones have to be the same also. So now we can set up a proportion to solve this. Give me a proportion we could set up.
5.5 feet over 3.5 feet
Okay,
is equal to x over 28 feet.
is equal to x over 28. X feet over 28 feet. Okay, that's one way. We can compare each of their heights to each other, then we can compare each of their shadows to each other. We can compare a height to a shadow, we can do it that way. We have a variety of ways we could do it. Go ahead and solve this now. I keep doing my decimal points as multiplication dots. Oh, what's half of 28? 14. What's 5 times 28? Well, what's 5 times 30?
5 is 30.
Oh my, we can't do that, okay. 150. Well, now we went too many 5 times though, so 5 times 2 is 10. So we take that 10 away from that 150 and we have 140, and you told me that half of 28 is 14, so is this 154? Anybody got their calculator out and want to check this out? So 3.5x equals 154. Do we agree with that? Yeah? Okay. Then we're going to divide both sides by 3.5. Remember, you're in some lessons you do get to use your calculator again. Thank goodness, huh? What is it? 44. And those are 44 what? Feet. And that's what?
Tall.
The height of a building. So the building is, sentence, the building is, this is the capital T. There you go, write it down. The building is 44, we don't put FT in our sentence, feet tall. Does that seem reasonable? Because the woman was taller than her shadow, the building is higher than its shadow. Okay, very carefully write this down before you leave me. This is due Thursday. And then we report to the senior high math lab directly tomorrow with your math stuff. Just bring your math stuff with you, as if you're going to come into class or regular class. Monica, you'll have to be public later for your down, and I'll even, and Caleb,